Alright, today we're going to look at some more problems with inverse functions. Then we're going to look at how to graph an inverse function. So first we're going to take a look at these two examples, number 1 and number 2. One second. Okay, I think those are the same ones. We're just also graphing. Okay. Alright, so let's start with number 1, 1/2 x minus 3. So we'll start by writing it as y. And then we will switch the x and y, so it becomes x equals 1/2 y minus 3. And then we'll solve this equation for y. So we'll add 3, which gives us x plus 3 equals 1/2 y. And then to get rid of that 1/2, we'll multiply by 2. And we got to multiply the whole side by 2, okay. So we're going to multiply this whole side by 2 and that whole side by 2. That'll get rid of the 1/2. And we'll be left with 2x plus 6 equals y. So our inverse function would be f inverse of x equals 2x plus 6. Number 2, the same thing. So this we write this as y equals x squared minus 1. And then we will switch the x and y. So this becomes x equals y squared minus 1. And then we'll solve this for y. So we'll add 1, which gives us x plus 1 equals y squared. And then to get rid of the square, we learned with quadratics, we'll take a square root. And don't forget plus or minus. So we end up with plus or minus square root x plus 1 equals y. And that's our inverse function. F inverse of x is equal to plus minus square root of x plus 1. Alright, now let's take a look at a graph and see what exactly does this mean for these to be inverses. Okay, so what I'm going to do is I'm going to set up a table here, and I'm going to use this table to graph a bunch of xy ordered pairs for the first. So this is the first problem, g of x equals 1/2 x minus 3. We saw that the inverse of this, so g inverse of x, was equal to 2x plus 6. Alright, this is the first problem. So I'm going to pick some xy ordered pairs. They can be anything we want. I'm just going to pick some that multiply nicely with 1/2 because whatever the x value is, it gets multiplied by 1/2. So I'm going to start with 0. 0 times 1/2 is 0, minus 3 is negative 3. Next I'm going to pick 2 because 2 multiplies nicely with 1/2. 1/2 times 2 is 1, minus 3 is negative 2. Next I'm going to pick 4. 1/2 times 4 is 2. 2 minus 3 is negative 1. And then I'll pick one more, 6. Half of 6 is 3. 3 minus 3 is 0. So I'm going to graph my inverse function, or my function here. So 0, negative 3, 2, negative 2, 4, negative 1, and 6, 0. Okay, so my function looks something like this. I'll color it in blue. Okay, so it looks something like this. Now my inverse function, if I want to set up a table for my inverse function, and I'll do that in red, okay? Then I could do the same thing, okay? I could just pick x, y values, or I could just pick a bunch of x values and plug them in, and get my y value. Or I can use the table over here. Now why can I use this table over here? Well, if I want ordered pairs for my inverse function, all I need to do are switch the x and y values. So 6 comma 0 becomes 0 comma 6. And 4 negative 1 becomes negative 1, 4. And 2 negative 2 becomes negative 2, 2. And 0 negative 3 becomes negative 3, 0. And this is actually my inverse function, and you can check these points. 2 times 0 plus 6 is 6. 2 times negative 1 plus 6 is 4. 2 times negative 2 plus 6 is 2. And 2 times negative 3 plus 6 is 0. When I graph these, I have 0, 6, negative 1, 4, negative 2, 2, and negative 3, 0. And I can connect these with the line. Now on this problem, it's not easy to see why these are inverses, okay? All that I've really shown is that the x and y values for the regular function and the inverse function are swapped. The reason that they're swapped is because if you look closely at the line that goes diagonally through the origin, okay, there's a line that goes diagonally through the origin and cuts this in half diagonally. Okay, it looks like this. Okay, this line cuts this graph in half through the origin diagonally. Okay, and these points are functions are reflections of each other across this diagonal line. And that's what it means for them to be inverses, is that they're reflections across this diagonal line. And this is the line y equals x. Okay, every ordered pair on this is the same. 1, 1, 2, 2, 3, 3, 4, 4. Okay, so these are reflections across this line here. And that's what it means for these to be inverse functions. Okay, they reflect across this green line. Let's take a look at the second function that we did. The second function we did was f of x equals x squared minus 1. And we saw that the inverse function for this one, f inverse of x, was plus or minus the square root of x plus 1. Well, let's graph this first function, first of all, by plugging in some x values. And I've already chosen some. I'm just going to plug them in and evaluate. So I'll plug in negative 2. So negative 2 squared is 4. 4 minus 1 is 3. Okay, I'm going to plug in negative 1. Negative 1 squared minus 1. So negative 1 squared is 1. 1 minus 1 is 0. Okay, let's plug in 0. 0 squared minus 1, negative 1. Plug in 1. 1 squared is 1 minus 1 is 0. And plug in 2. 2 squared is 4. 4 minus 3, or 4 minus 1 is 3. So let's graph what this function looks like, x squared minus 1. So we have the first ordered pair, negative 2, 3. Second ordered pair, negative 1, 0. Third ordered pair, 0, negative 1. Fourth ordered pair, 1, 0. And the last one is 2, 3. Okay, so this one, f of x here is a quadratic. It's a parabola. Looks like this. Now, if we think about what this should look like, what the inverse of this should look like, remember, the inverse should reflect across this diagonal line here. Okay, this green line, this diagonal line, the inverse of the blue function should be reflected over this line. Okay, so let's set up a table for the inverse function. All we have to do is flip the points. So we have 3, negative 2. We have 0, negative 1. We have negative 1, 0. We have 0, 1. and we have 3, 2. Okay, so we got, let's start 3, negative 2, 0, negative 1, negative 1, 0, and then 0, 1, and then 3, 2. And so this is what our inverse function looks like. And just so you know, this is not technically a function, okay, because it doesn't pass the vertical line test. This is actually a combination of two functions, positive square root of x plus 1 and negative square root of x plus 1. This is actually a combination of two functions. The first function is right here, which is positive square root of x plus 1, and the second function is right here, which is negative square root of x plus 1. Okay, because a function is not allowed to repeat x values. And you see right here, 3, negative 2, and 3, positive 2, that's a repeating x value. So this inverse function is technically a combination of two functions. All right, but regardless of that fact, you can see that the blue line and the red line, or the blue parabola and the red parabola, are reflections of each other over this green line. Okay, so graph the function and its inverse, and then we also want to write the equation of the inverse. Okay, so let's start by graphing the function. So we'll start by plugging in the x values. So negative 2 squared is 4, and 4 minus 6 is negative 2. Negative 1 squared is 1, 1 minus 6 is negative 5. 0 squared is 0, 0 minus 6 is negative 6. 1 squared is 1, 1 minus 6 is negative 5, 2 squared is 4, 4 minus 6 is negative 2. So our regular function, negative 2, negative 2, negative 1, negative 5, 0, negative 6, 1, negative 5, and 2, negative 2. Okay, so once again, it's a parabola. Our inverse function, we just need to set up a table where the x and y values are switched. Okay, so the first point would be negative 2, negative 2, because those are the same. The next one would be negative 5, negative 1, negative 6, 0, negative 5, 1, and negative 2, 2. Okay, so negative 2 is right here. Negative 5, negative 1, negative 6, 0, negative 5, 1, and negative 2, 2. Okay, so this is my inverse function. Once again, it's not technically a function, and that's because it's a combination of two functions. And we'll see in a second, we have to write the equation. So let's write the equation of the inverse for this. So we'll start by changing it to y. Let me do it in red actually so we can see that it's the red one. So we'll say y is equal to x squared minus 6. Then we'll switch the x and y. So x is equal to y squared minus 6. We'll add 6. So x plus 6 is equal to y squared. And then we'll take the square root of both sides, plus or minus. So we get plus or minus the square root of x plus 6 equals y. Okay, so the inverse function would be f inverse of x equals square root of x plus 6. And that's this function right here, the red one. Oh, sorry, plus or minus. And that's two functions. There's the plus function, which is the positive square root of x plus 6, and the one on the underneath right here is negative square root of x plus 6. Graph the function and its inverse. Okay. Alright, so just a reminder, this is the equation of a line. We could set up a table, but it's actually easier to graph it as a line. F of x is equal to 1/4 x minus 7, the slope, 1 over 4. The y-intercept is negative 7. So I'll go to negative 7, and that's the first point, 0, negative 7. And then my slope tells me to go up 1 and over 4. So up 1, and then 1, 2, 3, 4. And that's my next point, and that's the point 4, negative 6. And then if I want another point, I'll go up 1, and then over 1, 2, 3, 4. And that is the point 8, negative 5. All right, let's connect these to make a line. All right, so this is the graph of my original function. My inverse function is going to have, and you could do more points if you wanted to, it's going to have swapped. So it's going to be negative 7, 0, negative 6, 4, and negative 5, 8. All right, so negative 7, 0, negative 6, 4, and negative 5, 8. Okay, so it's going to be over here. And you can see they're reflected across that green line that cuts it in half. So remember the green line that cuts it in half is like this. And the function and the inverse are reflected across that line. Alright, and now all we have to do is make the inverse function. So we'll take the function and make the inverse. So we'll write it with y. Y equals 1/4 x minus 7. Then we'll switch them. X equals 1/4 y minus 7. And then we'll solve for y. Add 7. X plus 7 equals 1/4 y. And then multiply both sides by 4. And then multiply this side by 4. 4x plus 28 equals y. So our inverse function, f inverse of x, equals 4x plus 28. It's our inverse function in red, it's a regular function in blue, a table for both, and our graph for both. Okay, so we have everything we need for both of them. Alright, and then this is the homework. It says find the inverse of each function. You don't need to graph it, you just need to find the inverse.